Hi guys, my name is Mr. Lead, and today we're going to be doing an experiment. Now, I mentioned in some of my previous videos that one of the resources that our Earth gives us is fossil fuels. The three examples of fossil fuels are coal and oil and gas. So coal is a solid, oil and gas. Oil is a liquid, and natural gases are, well, it's a gas. Now, the way we find oil and gas in our Earth might not be the way you think. Some people think that deep underneath the Earth, there are just giant pools of oil, like this. But I can tell you, or maybe if we're talking about natural gas, like methane or something, and remember, this is oil and gas and all fossil fuels. Once upon a time, they were plant material, but they've degraded and turned into what we see today. Oil and natural gases don't generally get found underground like this. You don't generally see just a giant cavern full of oil. That's not really what you see. Instead, what you would more likely see is oil and natural gases being trapped within the dirt itself. And there'll be some patches of dirt where there's lots of oil trapped in it, and there's some patches of dirt where there's less. Now, that's typically what you'd find. And when we talk about this, we talk about the capacity at which this dirt or these sediments can hold the natural gas and the oil. Now, oil is not the only thing that sediments can hold. Water is another thing that sediments hold. And sometimes, instead of oil, we find underground water. And this is known as groundwater. A lot of the water we actually use in agriculture and elsewhere, a lot of the water we actually use is actually found from under the ground. Was once actually groundwater. So some of this, a lot of this water is just water that is captured and trapped within the sediments itself. Now, what we're going to be looking at today, because groundwater is such an important thing for our society, and because it's important to know it's therefore important to know what type of sediments we would be likely to see groundwater in. Now, as far as sediments go, when I talk about sediments, I can be talking about sand, or I can be talking about loam or clay. If you're wondering what's the difference between these things, well, the difference is there's grain size. So sand have really large grains. Well, I can't really show it to the camera, but when you pick up some sand, you can actually see each of those grains, and if you're careful enough, you can probably pick them apart. Loam, on the other hand, is much smaller. Loam is what you find most dirt to be made of. It doesn't have as many. It doesn't have grains as big as sand. And same with clay. Clay is even smaller than loam. So small that often you can't even see the individual grains. So that's the difference between these three sediments. So today we're going to be doing an experiment to test which of these sediments can hold more water than the others. Now, unfortunately, this isn't an experiment that you can really do yourself at home, but instead I'm going to do it here. I'm going to do it as a demo. I'll give you the results, and I want you to do the rest of the work behind the experiment for yourself. I want you to work out a hypothesis. I want you to try and articulate a good aim. I've explained for you what we're going to be doing. After this, I want you to record down the results and work out and write out the discussion and work out a good conclusion as well. Okay? So, I want you to follow all the normal Prac report procedures and show your knowledge of writing good Prac reports, but you're not going to be able to do the practice yourself, unfortunately. So, what I've set up in front of me, three funnels, each with a different sediment in it. We've got sand in this one, we've got loam in this one, and in this one, I'm yet to put clay. But before I put clay in it, what I've done for each of these funnels is I've put a cotton bud down the bottom. I haven't stuffed the cotton bud down because that could get it stuck. I've just put it there so that I can put the clay in. And the purpose of putting the cotton bud there is just that I can fill it up. I can roughly fill up the funnel without having the clay fall through. Now, what do you think would happen if I got a beaker and I filled this beaker up with 20 mils of water and I poured 20 mils of water into each of these funnels? Would we see any water drip through? Well, that's what I want you to hypothesize. I want you to take a prediction as to which ones we're going to see water drip through and which ones will, and how much water we're probably going to see drip through each of them. All right. So I'm going to fill this beaker up. Okay. I have 20 mils of water here. I'm first going to pour it into the sand. All right. Let's see how much water will fall through. By the way, the method to this can actually be found in your textbooks on page 98. All right. Oh, there's a bit coming out. It's not a heap. Now, it's fine for me to go back and pour more water into the sand, as long as I remember how much water I've poured into the sand initially. So this is my second 20 mils. So far I've poured 40 mils into the sand. So we're still seeing some water coming through. All right, so I have poured in the sand. I poured in 40 mils, and what came out of the sand was about, I'm going to say that's 24 mils. I've also made sure that there's no water sitting on top here, because if there's water sitting on top, then that's not water that's soaked in by the sand. So, 40 mils went in, 24 mils came out. I want you to work out how many mils is the sand holding. All right, let's move on to the loam. All right. That was 20 mils in. There's really not much coming out at all, though. Oh, it's getting there slowly. Tell you what, while I wait for the loam the water to soak through the loam, I'm going to pour this into the clay. All right, 20. Oh, there it goes. There's a little bit of water dripping out of the loam. Here's 20 mils poured into the clay. All right, it's taking a while for the water to come through soak through the clay, but I can see it. I can actually see it soaking through. I'm not sure if you can see it from the camera. This top part is really wet, and it's gradually, like this bottom part of the clay is dry, but the wet part is gradually taking over the dry part. All right. All right, I think all that water came through the loam. I actually still see some dry bits in the loam here, so I'm going to pour in another 20 mils into the loam. All right, this is the waiting game. Okay, I've reached a point where the dripping for the loam is finally pretty much stopped. And what's happened with the clay? No water has actually dripped through the clay's funnel, none at all. So here's what I'll do. I'll first measure the loam. It was about 21 mils that came out of there. So the amount that was poured in, 40 mils. The amount that came out, 21 mils. Now, for the clay, seeing that no water was actually that no water actually came out, you would think that I would say that 0 mils came out and 20 mils was poured in. But there's all this water that's actually sitting on top of the clay. That's not water that the clay has absorbed. That's not water that the clay is holding. All right. So what I need to do is I need to pour this water out. All right. Now with that in mind, when I measure this, I can say that it's about 14 mils has come out of the clay. Okay. So this is what you've got to work out. How much water is the sand holding? How much water is the loam holding? And how much water is the clay holding? So that's what you got to work out. Those are the results. And from there, there's some discussion questions, and I want you to fill out the rest of the Prac report. Thanks for watching, guys.